The U.S. is pressuring the Dutch company ASML to ban exports of some of its chip equipment to China.
Again, the 2020 data, they had shipped 258 units, Canon had shipped. But ASML has its own suppliers. So you have to say, okay, if ASML is the only supplier, who are the suppliers to ASML who might themselves have a lock on something?
From Orion X in association with Inside HPC, this is the At HPC podcast. Join Shaheen Khan and Doug Black as they discuss supercomputing technologies and the applications, markets, and policies that shape them. Thank you for being with us.
Hey, Shaheen, great to be with you again.
Great to be here. What is news today?
A number of things are going on related to geopolitical, supply chain, international trade restrictions, all of which relate heavily to technology, HPC, supercomputing. We're going to try to tie them all together and kind of move from one topic to the next. But the first one we wanted to look at was I had a very interesting interview recently with Earl Joseph at Hyperion Research, and they do a lot of research in China and looking at the differences between how exascale has evolved in China versus the United States now that the US has Frontier and we have a certified exascale system. But it's pretty interesting to look at those really rather significant differences.
Yeah, I'm really curious to hear more about it. When we've discussed it in the past, based on the data that has been disclosed by those systems, the architecture does appear to be more limited in terms of applicability. It seems like they're designed for a limited number of algorithms and may or may not be so general purpose. And then you fast forward to Frontier, which is way more general purpose, but then it relies heavily on GPUs, and that limits the scope of applications a little bit. And then you go to Fugaku, which I think is the most general purpose system out there, albeit now not as high performance as Frontier is.
Yeah, my sense in terms of China and exascale is there are two things going on. One are some of the trade restrictions has prevented China from accessing some of the most advanced technologies, including processors, which they've had to develop on their own. Now, I know that they also want to develop indigenous technology and not be dependent on other countries. But at the same time, they seem to have a slightly different outlook on the way that HPC is budgeted and planned for. According to Earl, they seem to have much more of a short-term view. They're buying supercomputing capacity for the needs that they have today. They're not necessarily looking out 2, 3, 5 years the way we do in the West.
Right. Well, of course, that could be a function of what can be done.
Yes.
And that may compel them to say, let's forego the bigger objective. Let's make sure the short-term objectives are met. And given that we don't have access to some of the merchant technology out there and have to roll our own, then let's do it the way they actually have done it. So that sort of makes sense, fits the data.
And Earl also said, the truth is they're really relatively new to HPC, again, relative to us in the US and in Europe. So that could also be a contributing factor in their outlook. But another really interesting phenomenon is apparently at some of the supercomputing centers in China, they're perfectly comfortable with limited use of their machines, maybe using 10% of the machine's capacity. Most of the focus, as he described it, was really focused on hero runs, very, very large problems, as you say, more of a specialized machine, which again is in stark contrast with how we try to use our high-end systems, our leadership class systems.
Yeah, I wonder if that too is a function of what we talked about just now, is that if you necessarily have to build a system that is special purpose because you're building the technology yourself and you're trying to meet a short-term objective, then by definition, it's not going to be effective for a lot of different apps. And therefore, when the app is done running, you wait until it needs to be run again.
Yeah, the analogy that Earl has run into at two separate places. The argument was, well, the supercomputer is like a hammer. It's a tool in the toolbox. If I'm not constantly swinging that hammer, that's okay.
Right.
Which, I think the counter to that would be yes, but a hammer costs $14.95, not $320 million. So, but in any case,
but really, that I'm kind of more and more convinced that this really is an artifact of the special purpose nature of the systems. Is that if you have a fighter jet, it doesn't have to stay in the air. That's not your metric. Whereas if you have a passenger jet, then you do want it to be used all the time.
Yeah.
Because when it's on the ground, it's not meeting its objectives. And so maybe that's what is causing it.
Yeah. And as we all know, the whole strategy behind these first 3 US exascale systems is building a whole exascale ecosystem, including a tremendous emphasis on software development that will run on these applications. And as Earl said, we've made progress doing this very hard work of optimizing software to run on exascale. So apparently, in that sense, too, we are out ahead of the Chinese.
I see. That's really good insight.
And that does relate to another key technology issue which came up last week, which is that the U.S. is pressuring the Dutch company ASML to ban exports of some of its chip equipment to China.
Right. Of course, ASML, as we know, is the leader in extreme ultraviolet technology. They really are the only vendor in the world that is supplying those systems. In 2020, I looked at that data, they had shipped 258 units, not all of them EUV, because they also do the previous generation DUV for deep ultraviolet, not extreme ultraviolet. But for extreme ultraviolet, they're it. And TSMC and Samsung have been their main customers. The big indigenous chip manufacturer in China, SMIC, apparently does not have those. It expects to receive them sometime in the next year or two. And I think that's where the news article is relevant to.
Yeah, we're putting pressure on ASML not to export DUV technology.
Oh, even DUV technology.
Yeah. U.S. is putting pressure on ASML not to export DUV technology along with EUV.
Okay. So even DUV is not okay. So they kind of, okay, that also fits the data. There are obviously sanctions about specific entities within China whose receipt of Western technology is being regulated. I think when the product is a US-based product, that's easier to enforce than when it's an international European, Asian product. And that requires more diplomatic measures to try to implement. But that's the times we live in. The geopolitics of life has been the same, more or less. That math is familiar. What I think is new is really the recognition that technology, especially semiconductor technology, is the engine of the next 50, 100 years of economic growth. And it is now a matter of national security, and therefore something we have to pay attention to and regulate.
Yeah, and this ASML technology is critical to the whole progression of chips moving 7 to 5 to 3 nanometers. And on the world stage, global competitiveness, this is a huge asset for the West.
Yeah, that's right. I mean, if you look at the fab equipment, TSMC and Samsung have EUV technology. The supplier of EUV technology is only ASML. They have truly a lock on that particular technology. Canon and Nikon, the Japanese companies that are better known for their camera work than fabrication equipment, are also big players, but they are DUV players. And even their DUV doesn't seem to be quite as up to speed as ASML is. So ASML has a lion's share of the market. Again, the 2020 data, they had shipped 258 units, Canon had shipped 122, and Nikon had shipped 33. And these are giant systems. These are a couple $100 million each. ASML's next generation system is reported to be something like $400 million per set.
Wow.
And then when you receive them, it's not just you turn it on and you're good to go. You have to tune it. And TSMC has special expertise to do that better than anybody else right now. Of course, that's sort of, I mean, there's a whole lot of variables involved, but they are ahead of even Samsung with EUV equipment.
We did a little research on this yesterday. It was actually TSMC that was an early pioneer in this ultraviolet area. How it evolved over into ASML, but it does go way back with TSMC.
It does go way back. I mean, the whole technology goes way back to the 80s, and there have been several breakthroughs to get it to where it is today. Our own Livermore National Labs has been one of the pioneers in the US in that technology. But it seems like TSMC had some breakthrough some years ago, and they decided to bet on the technology, and ASML adopted it and had their own breakthroughs. And the two of them have been the duo that have been pushing it until Samsung got in and now Intel and others. But ASML has its own suppliers. So you have to say, okay, if ASML is the only supplier, who are the suppliers to ASML who might themselves have a lock on something? And there are a few that are stronger than others. You know, you have to get masks. Their masks come from the Japanese. The software for mask comes from Japanese. The companies like AGC and Hoya do the masking. NCS does software. The light sources come from the US, so the company down in San Diego. The lenses, the optical modules, so to say, come from Zeiss in Germany. Then you've got metering, you've got conveyor belts, you've got, all these other things that are coming from all over the place. But substantially, their suppliers are Western suppliers and or fellow Dutch suppliers. So the West could, in fact, pressure if they aligned around it.
Well, I'm looking forward to our next episode because I believe you're going to give an hour-long presentation on how EUV actually works.
That's right.
That'll be really fun.
I do know a couple of people who could probably do this. And I asked them, but this stuff gets so complicated so fast. And I really feel for politicians who, may not really have the background. So, yeah.
Exactly. And what ASML is doing, the secret at the center of how chips are getting and systems are getting denser and denser. It's amazing what they've done.
Yes, absolutely. Absolutely. Maybe a segue into software.
Yeah.
You mentioned the exascale software, and we really need to come and talk about software as we systematically go around different aspects of supercomputing, in part because there was a time when you had the system, some disk was attached to it, you had an operating system, a compiler, and you were good to go. Maybe some libraries. Now, what used to be the OS compiler library is now a vast universe of software going from microservices to API libraries to, package management and workload management, all of that. And what used to be disk is now this universe of volume management, computational storage, file systems. And of course, we covered storage with Gary Greider a few episodes ago, and that was a fabulous episode as well. System management, federated computing, networking, compute, all of those. It's just such a tall stack of software layers that even drawing it on a slide is hard to do, let alone trying to put our arms around it but we're going to want to do that. So I think, stay tuned as we go after the software piece of the puzzle and try to systematically shed light on what's going on in each aspect of it.
Well, as the cliche has it in HPC, hardware is easy, software is hard, and we do want to increasingly put a spotlight on the software end of things. And we're very open to suggestions. Guests who have expertise in this area that would be interesting to talk to.
Definitely. And I just want to add, this is when the hardware is actually pretty hard.
We're talking relatively.
Yeah, relatively speaking. Yeah. That's right.
So very good. All right, Shane. Well, as usual, it's been a pleasure to be with you.
Likewise.
And we'll look forward to talking again.
Thank you so much.
Thanks.
Take care.
That's it for this episode of the At HPC podcast. Every episode is featured on InsideHPC.com and posted on OrionX.net. Use the comment section or tweet us with any questions or to propose topics of discussion. If you like the show, rate and review it on Apple Podcasts or wherever you listen. The At HPC podcast is a production of OrionX in association with Inside HPC. Thank you for listening.